Let's say we have a block with a mass of 5 kilograms, and we push on it with an applied force of 40 newtons. And the block accelerates at 7 meters per second squared. First thing we need to do is draw a picture. Draw a little free body diagram here. We've got our block. Okay. The block is not moving up or down, so our gravitational force, or the weight, the mass times gravity, would be equal to the normal force of the block. Our applied force is 40 newtons. And we are looking for the frictional force acting on the block. Well, we know that the net force is the applied force minus the frictional force. No matter how hard you push, friction is always going to oppose that motion, so you have to account for that. Now, the mass of the block is 5 kilograms. That is the actual mass of the block. The block itself is accelerating at a rate of 7 meters per second squared. So that is our net force. That is the force the block actually has. We know our applied force is 40 newtons minus the force of friction should equal the net force. So 5 times 7 is 35, and we would have a kilogram meter per second squared, or a newton, and that would equal 40 newtons minus the force of friction. If we move the force of friction to the other side and subtract 35 newtons from each side, we would get a frictional force of 5 newtons. All right. A couple other things to consider on these types of questions. Let's say that we have an object and the applied force is, say, 10 newtons, but this object is moving at a constant velocity. Well, if the velocity is constant, that means acceleration equals 0. And if the acceleration equals 0, there are no, this is important, net forces acting on the object. That's no net forces. There's still an applied force of 10 newtons, but what that means is it's just enough force to overcome the frictional force, which is also 10 newtons. So when an object is moving at a constant velocity, the applied force and the frictional force have to equal, because the sum of the forces, or the net force, has to be 0. Now, we can also look at this vertically. Let's say you have an object falling through the air. Okay. Last module we learned that the acceleration, the rate of acceleration would stay the same, but the object would increase speed in the absence of air. But we do know that there is air resistance. Air resistance is a lot like air friction. Air resistance opposes the motion of objects falling through the air. As an object falls through the air and gains speed, the air resistance increases, and there becomes a point where the air resistance is the force of the air resistance is equal to the downward force of the object, and the object no longer increases its speed, but it falls at a constant velocity. In this case, that constant velocity is referred to as terminal. Oops. Let me write that a little better. Referred to as terminal velocity. And all that means is that the upward force of air resistance is equal to the downward force of the object, and the object stops accelerating and moves or falls through the air at a constant velocity.